Hi, and welcome to this tutorial. In the last tutorials we focused on how to rig a 3D model in Blender and how to let it move by the Kinect data using TouchDesigner. Thank you for all the comments and subscriptions. If you're interested in the work files, you can support us on Patreon, but we'll assure you that if you follow along our free videos and maybe a little trial and error of your own, you can get the same result. Since we're an audio-visual label, we're also looking for solutions how to create that steady in-sync audio-to-visual effect, like you see in live shows or VJ performances, or for teaser videos we did for a client like this one. A way to do that is to use MIDI data and convert this to comma-separated values. Maybe you find working with keyframes and/or F-curves a bit intimidating, or you're more focused on audio than visuals. I will isolate a couple of elements like scaling an object, modifying an array, and controlling the strength of a light source. We'll start off in TouchDesigner and import a MIDI file and set up a network that will export the MIDI data to a CSV file, like this one. This text file will be imported in Blender, where we use the animation nodes add-on to use the CSV data as a trigger for transforming an object. So let's get started. So we're in TouchDesigner. I'll start off with a MIDI in chop. Select the MIDI file. Maybe you received one from a client or a partner. This one happened to be one I've created on my own. This is how it looked like. These are the MIDI notes. This is the waveform of the song itself. What I did, I've placed MIDI notes on every element in the rhythmic section, like the kick, the hi-hat, and this is a bass line. It works very well if you use very steady triggers like kicks, snares, hi-hats, crashes or bass lines. It will give a very nice steady in-sync effect. This happened to be a song of my own, but when you receive a MIDI file from a client, there are two things you need to be aware of. That's one is the beats per minute of the song where the MIDI file is based on, and two, the frame rate of the movie clips you are going to export to. In this example, the beats per minute happen to be 135. And the frame rate where I'm going to export to is 30 frames per second. Okay, so this is the MIDI file. I change this one to 1. And the scope to everything. Let's look at the info. There are a lot of MIDI channels. When you import a MIDI file, it shows you all the possible channels it can give to you, but we're going to isolate it anyway. We can do that by an analyze job and look closer to see which channels are actually receiving any input. That's 48 to 53. So what I do, I set the scope of the MIDI chop in to 48 to 53. There they are. I can delete this one. And now an important thing the MIDI file is based on a speed of 135 beats per minute, and TouchDesigner is working in frames per second, and the movie needs to be exported to 30 frames per second. So you have to do a little bit of mathematics and adjust the sample rate of the MIDI file, because what it basically says right here is that every beat has a duration of 60 frames, and that's not what it's supposed to be. It has to be much faster. So what you do is, first of all, you going to calculate the frames per second to frames per minute. So we multiply it by 60. And now we'll divide this 800 frames per minute by the beats per minute. So divide. So 13.33 frames is the duration of one beat. So we'll put a null here. We're going to drive the sample rate with this value. So this mini channel is now working at 135 beats per minute. In the MIDI chop, under the note channel, we also have to isolate the velocity channel. Select a separate channel. The velocity name is V, and we don't want it to normalize. We want the full range. If you look at the channels, some channels has an N, some channels has a V. The N stands for note on and off. That has a range between 0 and 1. 0 is off and 1 is on. But we need a little bit more data, so we isolated the velocity channel. The velocity within MIDI has a range between 0 and 127. It's based on someone who recorded the MIDI file. If he or she plays a piano, the harder you press a key, the higher the value of that velocity will be. So we're going to isolate two channels. This one will be the note on off, and the other one will be the velocity. You see, this one has a different range. You see here between 0 and 100, and this one has a little bit more dynamic. If I zoom in, yeah, it's more dynamic than. I happen to know that the first one is the kick, and that's basically just note on, note off from a velocity between 0 and 100. But when we exporting this to comma separated values, we want a very nice roll off to give the animation a bit more dynamic, because when it just is one note on, one note off, it's very static and it doesn't give a very dynamic and lively feel to it. So we're going to multiply these two with each other. So pick a mat chop, combine chops, multiply. So now we have the note on and the velocity all together. To actually give your animation a nice attack and a nice roll off, like I've shown you in our examples, you need to adjust the attack and the decay of the trigger. And you can do that by a trigger chop. Set this one to time slice off, so it's looking at the entire range and not just at the specific frame at a specific time. When I happen to know that the first channel is the kick, when I'm animating a transformation based on a kick, I want a nice attack and a nice easy roll off to give the animation a bit more dynamic and a bit more character. It's going to be very stiff if it just note on, note off, and it's not going to give a very nice result. So if we look at the values, when you insert a trigger chop, it's already adjusting the peaks of the notes. When I'm looking at this one, if I zoom in, this one is just note on, note off, and this one has a different attack to it. So you can adjust this by changing the attack length. So I don't want it to be that long. I think this one will do the trick. So kick it's a powerful sound, so it doesn't have to be that slow. I think this one is nice. The sustain will tell you how long the beat will hold. Most of the times a kick is quite short, so it doesn't have to be very long. And the decay length will tell you how long it will take to roll off the sound of the kick, but in this case the roll off of the animation itself. So from my experience, I think this will do the trick nicely. The trigger chop changed the range back to 0 and 1, so you have to put a math next to it, adjust the range to 0 to 100 again. And that's it for the chop world. We now are going to export this null to a table. So go to that, chop 2. So this is the table. You already can see that it created a roll off. So when I'm bypassing this, all values are more stiff, and this gives a roll off to the actual data. I think I'm going to adjust the attack a little bit, make it a little bit because it's a bit harsh if it just immediately starts with 100, so that will do the trick. In order to convert this to comma separated values, we have to get rid of the column separation, and you can do that by use an convert, this one. You create this one to text, and the separation needs to be a comma. So this is going to look more like the file I've showed you in the beginning. And this is basically it. Close it up with a null. And in order to export this to an actual text file, we're going to write this one to a text file. Select text. I already happen to export one, so I skip this one. Just press right and it will export this text file to a file with all the comma separated values, which we will going to be imported in Blender. So I'll see you there. So we're in Blender now. We'll start off with a simple scene. Make this a little bit bigger. Ctrl A. Apply rotation and scale. Put on the screencast key so you can follow along. Shift A. We'll use an icosphere. G to move, Z to isolate, bring it a little bit up. Okay, this one will do the trick. I'm gonna hide this window. I'm gonna drag any one from here and the one from below. In order to import the CSV file, we'll go to the text editor. We'll press open. Look for the file, we've just exported it, and there it is. Put this one in the node editor. In order to work with animation nodes, you first have to enable the animation nodes add-on. I believe it's standard inside of Blender, but you have to enable it first. So you go to File, User Preference, Animation Nodes. Make sure you check this checkbox and save the user settings. So we're in the node editor. Make sure you're in the animation tab. I think the default will be the material one. If you're in cycles, make sure you're in the animation node editor. We'll start off with a new node tree. And in order to get the CSV file inside a node, we'll use Shift A. Go to text, a block reader, and in this field we'll choose the actual text file. So first of all, every line in the CSV file stands for a different frame. So this is the first one, the second one, the third one, and so on. So we want Blender to use the frames as a separator between the lines. So when I'm on frame 40, it actually has to look at line 40 in this case. So we'll use a text splitter. You can look for it by pressing Shift A, split text, but you can also use Control A and just look for it. It works either way. So we want to look at the different lines. To get the actual line based on the position of the frame, you insert a getList element, connect this one, and the index needs to be driven by the frame info. So if you're not sure what this output is going to be, you can always use a viewer. So in this case 0 is the first line, this is the second, so it's corresponding nicely, but I don't want to do this manually, so I'll use the time info. So when I'm flipping between all these different frames, you'll see that the output of the getList element will be synchronized with the CSV file's line separator. And now we need to create a parameter to split the different columns based on the comma, and we will do that by a subprogram which will function as a loop. Shift A, go to subprograms, invoke subprogram, press new subprogram, select loop, and you get a separate chain. So this program will function as a clustered operator where different steps will be taken. I call this one split column. Press this plus sign, convert this to a string or a text list, so we can connect this one, create a new parameter, and that will be an integer. So it's the same we used here. And this one is going to be controlling the different channels where the animation is looking at. So in this case it's looking at the first column, this one to the second. So we'll do a split text again, but in this case we're going to let animation nodes look at a specific separator, and that will be a comma. Connect this one, and again the get list element will be driven by the integer. So, and in order to close this one up so we can get an actual output here, we'll press the new generator output, and we're going to output this one as a text list. So if we're going to check the viewer again, if we move between, you see that This is the first line, 0, frame 0. First column is a 0, second one is 0, third one is 41. So that's working fine. Okay, we'll start with a get list element again. I'm going to convert this to a number. Draw a number, parse number, so the text will be converted to a number, so we can connect this one to a math node. Put this one to 0 for now, or 1, sorry. And now we're actually able to drive this value to an object transform output. So we select the icosphere here. This one stands for transformation, rotation and scale. We pick the scale for now. And in order to connect these two, we need to convert the number to a vector, because these are vector values. I believe it's vector from value, yeah. And this one, connect that one. You see that it's actually disappeared, but that's a good thing because we're in frame 0. And if you look at the CSV file, the value is actually 0. So if we're going to the second one, it's 50, and that's quite big. And if you go to the third one, it's actually getting bigger because it's 100 up here. So we'll do something within the math job. We'll multiply it by 0.01. So that's a bit more cleaner. You see that it's already starting to animate. But I want that the icosphere is always viewable, so I'll put another math behind it. So I duplicate it and I set this one to add, this one to 1. So when I'm moving it now, it's always showing up. So when I press play, you see it's already moving, but the effect will be much better if I'll put on a music strip underneath it. So what we can do, we go to the video editor, we go to add sound, and I'm going to pick the actual song, put it in here, and if I'm pumping up the speakers, think you will actually able to see and hear. I think I have to adjust the to the default again. Yep, the frame rate needs to be 30. So if we try it again. Now it's lining up quite nicely. I think I'm going to make it the difference a little bit bigger, maybe 0.5, which gives a much more dramatic effect. To change the range, make it a bit longer. Maybe I think 9000 will be enough. So that's it for the transformation. I've also shown you an example where the icosphere gets modified by an array. So I'm going to disconnect this one for now. Oh, I'm just deleting it. Where is my icosphere? Yeah, the scale is changed, so I put this one back to 1 again. Yeah, there it is. Going to move this aside, make it a little bit smaller. It's for the array modifier to be noticed a little bit better. Ctrl A to apply the rotation and scale. So in the modify tab, this tool-ish icon at modifier array, you can change the count. I happen to know that the kick has a value of 100 at top, so I'll just use a count that is easier dividable. So I'm going to change the offset a little bit. Okay. But we're going to drive this count with a node, and in order to do that is an object attribute output. And what this does, you can hover over this count parameter, right click, and if you copy the data path and paste it in here, and you select the icosphere, you get an error, but we can fix this by deleting this math, put this multiplier to 1 again. These values are actual float values, and this count value are integers, so we have to convert this float to integer. I believe it is called float to integer, okay. Yeah, I believe it's actually working already. 50, yeah, that's a bit. I think I'll put this one to 0.0 again. Yeah, now it's 5. So when I press play now, you see with a couple of small adjustments you already have a very different effect, but a real-time animation and perfectly in sync. And the last example I'm going to show you is how you can drive a light source and the strength of the light source by the comma separated values, and therefore we're using an cycles material output. Make sure you're in the cycles renderer. First of all, you need to apply a material to this icosphere. So we're going to create a light source of this icosphere, and we'll do that by choosing material, the emission, and the strength will be driven by the CSV file, and we do that within cycles material output. This happened to be material, or called emission, and yeah, there it is. We need to control the strength of the emission. So let's see if we can. Okay, we have to select emission again, because this is the name of the material, and here you select the material itself, and you select strength over here. These are actual float values. You can see this by the same color. So if we hook this one up, it will connect. And from my experience, the strength needs to be a little bit higher, so I'm going to multiply this one by 10. So if I put this one in render view by pressing Shift C, you see at frame 0 it's still dark, and if you flip through it, it stays dark. Let's see what's actually happening here. Always Always check the viewer, what it's actually outputting. Thousands. Yeah, it's actually moving along, so it should work. I'm not sure why it's not working. Try it again. Ah, there it is. It's a bit difficult to see because we're in render view now, so it's much slower. So when I press play, I don't know if you was actually able to hear me, but you see that the strength of the light source is actually driven by the CSV file, because we're in render view. It's not perfectly in sync because yeah, the render view is much slower than the viewport. But when I press play here, you won't be seeing anything. Blender is heading towards the release of 2.8, and of course animation node is, I believe, also releasing a stable version for 2.8, and I think you can do much more real-time experiments with lighting with the EV renderer, so the result will be much quicker and opposites to cycles, where you actually have to render the file to see the effect of the light source. But she's actually working, and that's the most important thing. So I've shown you a way how you can use your comma separate values to drive a light source, the transformation of the icosphere, and then to transform a modifier, and in this example an array modifier. We'll be happy to see any examples or experiments based on this technique. Feel free to contact us for any questions or critiques or tips and tricks. Our videos will always be free, but if you're in a rush or in a hurry, our work files can be downloaded at our Patreon for a small donation. We're currently working on a new tool where you can import a MIDI file and it will immediately export a CSV file. That could be a text file or a 3ds Max script or a script for After Effects. So stay tuned, we'll keep you posted. Please subscribe, give us a thumbs up, and that will provide us with a lot of energy to keep up the pace and provide you with lots of new techniques or things we like, and we hope you will like it as well. So keep it up, and we'll see you next time.